Okay, can you see the screen?
Yes, sir.
Yes, sir.
Okay, so what we were talking about yesterday, subsequence of a sequence, right? So, in a sequence xn, right? Given a sequence xn and nk is strictly increasing, sequence of natural numbers, right? Nk means what varies here? K varies, right? Then if you look at xnk is a subsequence of xn. So nk is a subsequence of xn, right? This is what we discussed yesterday. For example, if you look at sequence, for example, let xn be a sequence and nk is, for example, 2k plus 3. This is a sequence of natural numbers. Now, what is n1, n2, n3, n4, in general nk? Correct? Do you understand what is n1? What is n1?
5,
5. Very good. What is n2?
7,
7. What is next? n3?
9,
9. 5, 7, 9, 11, and so on. And nk is 2k plus 3. Right. So as k varies, this varies. Now, if you look at original sequence xn, what are the terms? x1, x2, x3, x4, and so on. Now, what is xnk? Xnk is actually, what is it? Xnk is 2k plus 3. So x2k plus 3. And what are the terms of this sequence? Right. What is first term? xn1, xn2, xn3, xn4, and so on. But what is n1? xn1? x5, because n1 is 5, n2 is x7, right? x9, x11, and so on. So original sequence is x1, x2, x3, x4, and so on, and the subsequence is x5. That means x2, x3, x2, x1, x2, x3, x4 are deleted. Which terms are deleted from this? Up to x4, then x6 is deleted, x8 is deleted, x10 is deleted, right? So in this way we got a subsequence, same terms, right? So let us see particular example. Let xn is equal to 3 upon 5n plus 7. This is my sequence, correct? So what is x1? 3 upon 12. What is x2? What is x2? 3 upon 17, and so on. You can calculate all the terms. Now suppose nk is equal to 2k minus 2k plus 1, right? So is it nk strictly increasing? Because we need strictly increasing, otherwise that will not be a subsequence. So what is nk? 2k, k is equal to 1, then what is it? What is nk? 3, 5, 7, 9, 11, and so on. This is nk. So what is xn? X 2k plus 1, correct? And what are the terms here? x3, x5, x7, x9, x11. These are the terms. And therefore, what is x3? What is x3? What is xnk? What is xnk actually?
3/22.
So 3 upon, so xn is 3 upon 5n plus 7. So what is xnk? 5nk plus 7, right? 5nk 7, xnk 5nk plus 7. But what is 5nk? What is nk? 3 upon, we will get direct formula for nk, xnk, right? So what is 5nk? Nk is 5 times 2k plus 1 plus 7. So this is 3 upon 10k plus 12. This is a direct formula for xnk, right? And therefore you can write the terms of x and k. And what is vary here? K varies, and so we'll get successive terms. So for n is equal to 1, what is xn1? What is xn2? What is xn3? And so on. xn1 is x3, xn2 is x5, xn3 is x7, and so on. Right. So what is x3 now, or xn1? xn1 is same as x3, but in terms of k we have direct formula, that means k is equal to 1. What is it? 3 upon 22. Am I right?
Yes, sir.
Yes, sir.
What is next? What is next? 3 upon 32. Am I right? Next is 3 upon, what is xn3? So 30, so 42, and so on. This is a subsequence. Right. So this is a first term in subsequence, but it is third term in original sequence. This is second term in subsequence, but it is fifth term in original sequence. So that is what we discussed yesterday. Now, if nk is equal to k square plus 1, then what is xnk? Right? It is x k square plus 1. But what is xn? Xn is 3 upon 5 times n plus 7. But n is what? K square plus 1. Right. So ultimately, what is it? 3 upon 5 square plus 12. 5k square plus 12. Right. So in this way, you can calculate now x and k. What are the terms of subsequence? Right, so you see why I'm doing this again and again, because you need to understand what is the difference between what is the relation between terms of subsequence and same terms, but we are deleting some terms, and therefore due to deletion the terms get shifted to right hand side, their position is reduced. Xn is equal to minus 1 to the power n. Then you find if nk is equal to 2k, then find sequence xnk. Right. Second question, if nr 2r minus 1, then find xnr. Right. I am using different notation due to some reason, because here it is nk and it is nr 2r minus 1. And what are these sequences? Can you understand? Can you write the terms?
First sequence all terms are 1 and
Ah,
second minus 1.
so nk is 2k, means it is even. That means you have to just catch the even terms, right? Even terms means what? X2, x4, x2, x4, and so on. But what is x2? 1, 1, 1. So 1, 1, 1, all constant, right? And what is xnr? Nr is 2r minus 1. It is odd. X 2r minus 1 odd. And what are the terms? X1, x3, x5, and so on. And what are the corresponding terms? What are the corresponding terms? Minus 1,
Minus.
Minus 1.
minus 1, minus 1. Now, what is important observation here? What is important observation here? limit, now k tends to infinity xn k. What is the limit of this sequence xn k?
1.
1, right? Constant, because it is constant sequence. Second thing, what is limit as r tends to infinity xn r, second subsequence? What is its limit?
-1.
-1, right? So second sequence we have to just accepting odd terms with odd suffixes and neglecting terms with even suffixes. In first subsequence we are accepting even suffixes and neglecting or avoiding odd, so in that way, but both subsequences converge. But limit of xn does not exist. Is it clear? Limit of xn does not exist. Am I right? Subsequences
Yes.
converge.
Yes, sir.
So this is what happening in this case. But you look at another example. Look at another example. Xn is equal to 1 by n, right? And you look at nk is equal to 1 upon k square plus 1. Then what is xnk? What is xnk? What is xnk? 1 upon nk. Because xn is 1 by n, so xnk is, right, suffix is now nk. So xnk is 1 by nk k square plus 1. Correct?
So it should be 1 by k square plus 1, no?
So yes, 1 by k square plus 1. That is what I have written.
Actually, so nk is equal to, you have written 1 by k square plus 1, then in
No,
the
no, no, no.
denominator.
What is xn 1 by n? What is x5 1 by 5? What is x100 1 by 100? So what is xnk 1 by nk? Am I right?
Yes, sir, but actually nk is equal to 1 by k square plus 1, no? So in denominator it should be 1 by k square plus 1.
You can't see the next step. I have written something after 1 by nk.
No, sir, actually.
Yeah, I have written that 1 by nk is equal to 1 by k square plus 1. Because nk is k square plus 1.
So nk is 1 upon k square plus 1, no?
Yes, sir. It should be 1 upon k square plus 1.
Oh, sorry. Correct. I wanted to say that nk is, I just had kept in mind that k square plus 1. So it is k square plus, because nk should be sequence of natural numbers, suffixes. Okay, is it clear now?
Yes, sir.
Fine.
So
So what is limit of this sequence? So limit as k tends to infinity, because now what is changing k? K is a position in subsequence, so k changes. Right. So what is limit as k tends to infinity? 1 by k square plus 1. What is this limit?
0.
0. Very good. Or now if I look at, okay, this is my one subsequence. I am looking at another. Nk is equal to 2k. Then what is xnk? 1 upon nk. It is 1 by 2k. And then what is limit of xnk?
0.
0. 0. Here limit is 0. Okay, let us see another odd suffixes. Nk is equal to k minus 1. Then what is xnk? 1 upon 2k minus 1. And therefore, what is limit as k tends to infinity? Xnk?
0.
0. So here every time limit is coming out to be 0. And on the top of that, what is limit of original sequence xn?
0.
Limit is also. So here uh, we saw some subsequences, their limit is 0 and limit of original sequence is also 0. And in previous example, limit of subsequences exist for some subsequence at least, but the original sequence does not converge. So that is the main issue which we are going to discuss, right? And so what is the significance to study the subsequences, right? So if a sequence xn converges to a real number x, then then every subsequence of xn converges to x. Right? If original sequence converges to x, then every subsequence converges to x. See the second example. One original sequence is xn, right? And where it converge? 0. Am I right? Correct?
Yes, sir.
You look at any subsequence of this sequence, every time the subsequence also converges to 0. Here we didn't have any choice. In first example, our original sequence is not convergent. Therefore, that property of this theorem, the statement of theorem fails here, right? Because one subsequence converges to 1, another subsequence converges to -1, right? So the statement of theorem fails here. Because why fails? Because the original sequence is not convergent, right? What statement of theorem says? If sequence xn convergent and it converges to x, you choose any subsequence, that subsequence must converges to the same number x. Same number x, right? No choice. The statement is clear?
Yes, sir.
Statement of theorem is clear?
Yes.
Fine. Importance of this theorem that we'll discuss later on after the proof. Okay, so what is given? What is given? Xn is a convergent sequence of real numbers. Right, so this is given. And second thing, limit of xn is x. This is given. What is our claim? Every
Limit.
subsequence of xn converges to x. Right, this is our claim. Means what? Okay, how many subsequences of a sequence are there in any sequence? How many subsequences we can produce? Right, this is a basic question.
Infinite.
Infinitely many, right? You can produce many subsequences. Whatever how many subsequence you want, you can produce actually. You just delete some terms, accept the remaining terms, delete some different terms, whatever is this. So you can produce infinitely many. So there are infinitely many subsequences of a sequence, right? So what we want to prove, suppose I have a box, right? I have a box containing all subsequences of a sequence, right? This is a box and I have a sequence. I will put all the subsequences in this box, right? What is this box contains? Subsequences, right? For example, I will look at x2k, x2k minus 1, xk square plus 1, x5k plus 7. So whatever you want, all subsequences are in this, right? All this. And what is our claim? Ki every time, that means you just close your eyes and select one subsequence, just put your hand inside the box and select a subsequence. Limit of that subsequence is also x. Is it clear what we want? Is it clear?
Yes.
Yes.
So therefore, what is our claim? if x and k is any. Any means what? Just close your eyes and select a subsequence. Right? Any, no bias. Just close your eyes and select a subsequence. If x and k is any subsequence of xn, then limit as k tends to infinity xn k is x. This is what our ultimate aim. Once our aim is clear, then we can decide our strategy. Right? So what is our strategy? Our claim is clear, so what should be the strategy? Our aim is clear. What is the strategy? Logically, see, your logical understanding should be clear. Forget about what are the calculations and how big is the proof, how to prove some theorem. That doesn't matter. That you can achieve anytime. But your logically, the thing should be clear. What exactly I should.
For
We'll
given
consider
any
later.
epsilon, we can produce k.
That is the later thing. How to start? Suppose this box contains fruits. I am giving same example again and again. This box contains a fruit and I have stated some condition on fruits in this box. What condition I have stated? What are fruits now? Sequences. Each fruit is a one subsequence. This fruit is a one subsequence. This fruit is. So what is the condition I have stated here on the fruits inside this box? Every subsequence converges to the same number x. Same number x is fixed already, which is a limit of xn. That means suppose I say that every fruit inside box is a sweet. How will you prove it?
We'll consider any subsequence means general for
Right.
general k.
I will open a box and I will close my eyes and first I will select fruit. I will first select fruit and then I will check whether it is sweet or not. So what is the naturally, logically what I should do? First of all, I should select a subsequence and then I will prove that it is converges to x. This is logically clear, right? Don't say ki epsilon and all this, that comes later, right? What I have written in red color is our aim. Ki if you select any subsequence, it converges to x. That is our aim. And so now our process starts. So how does process starts? First select any subsequence and then prove that it converges. So how to start the process? Let x and k. So let x and k be any subsequence, right? Is it clear what I am saying is logically correct? Do you understand?
So,
Yes, sir.
Yes. So whatever I am saying, you should understand whatever I am saying, it makes sense. It is necessary actually. Let x and k be a subsequence of xn, right? There are many, but I am just arbitrary closing I just close my eyes and select. And then I am going to prove that it converges to x. Right. Then I understand that we claim that so limit of x and k as k tends to infinity is x. This is our claim because limit of xn is x. So this is our claim. Okay, now now what is our next task? We want to prove that limit of this sequence is x. So what to do to achieve this task? How will you prove that something converges to some number? How to prove something converges to some number? Yes.
If it is monotonically increasing and bounded.
There is no question about increasing. We are just arbitrarily selecting. There is nothing, there is no information about monotonically increasing or decreasing at this instant, right? How will you prove that something converges to some number? So given epsilon, right? What is our claim now? See, we are working with very general sequence and therefore there is no specific information like whether it is monotonic or not. Right, so monotonic and all these things are very about the specific sequences. Those are monotonically increasing and all this. Right, but we are doing in this for general. So monotonic increasing or decreasing doesn't make sense in this case actually. Right, and so we should look for some general way. What is a general way? That
For
is,
given epsilon greater than 0,
Given
we can
epsilon.
find k.
there exists k such that k is this k is a capital K. Remember this. There is k such that xnk, this suffix nk is a small k, minus x is less than epsilon for all this small k greater equal this capital K. If we achieve this, then what we can say, as k tends to infinity, xnk tends to x. Am I right? So this is our claim. See, if you have difficulty, you can ask me, but logically things should be very clear. Unless things are clear, the rest of the part doesn't make sense. Right, you can do calculations, you can write down calculations in exam, but that is not sufficient. Have you understood logically what you are writing or what we are writing on here? Correct.
So can you repeat once again the last step, that is given epsilon?
So we want to prove that the limit of something tends to, see, go to the previous examples that we check. How will you prove that xnk converges, xnk in this case is 1 upon 2k, and how will you prove that its limit is 0? You said that limit is 0. How will you prove limit is 0 in this case? Given epsilon, there exists k such that 1 upon 2k minus 0 is less than epsilon. Given epsilon, there exists k such that this less than epsilon for all k greater equal k. Right? What is the meaning of
Yes.
limit? Right. So here our aim is to prove that limit of this subsequence is x. Means what? That means as k tends to infinity, the x and k tending towards x. What does it mean by definition of limit? Given epsilon, can you produce k? The terms are in epsilon distance from x after k. Is it clear?
Yes, sir.
Right. So this is our aim. And so now what is the next task? First task was select subsequence. And then we understand that we want to prove that its limit is x. And therefore, what is the next step? We
Produce.
understand limit of x and k is x. We want to prove this means what? Means what? Given any epsilon, we are able to produce k. This we want. So how to start the next step? Given epsilon, right? What we want? What we want now? K. Given epsilon, can you produce k? X and k minus x is less than epsilon after k. Right. So given epsilon. Okay. So so what? Since what is given data? What is the assumption? What is
Limit
the
of x is x.
limit of xn is x. Limit n tends to infinity, xn is x. Therefore, for every epsilon there is k, right? Therefore, for in particular for this epsilon also there exists some, what I should say, some k or n. What I should say here, I should say n here, because notation might be confusing, so don't get confused among the notation. There exists n belongs to n, natural number n, such that what?
Distance between xn and x is less than epsilon for n greater than or equal to
This
n.
particular, right? After this will happen because xn converges to x. Fine. But what is our ultimate aim? Our ultimate aim is this. We want to find k such that this happens. Whatever I have written in bracket, that is our aim key. I want key xn k minus x is less than epsilon. Right? So what? Yes. Or actually there is no harm in calling this as a k, right? Why, that we'll see later on. But anyway, there is, so notation, there should not be confusion among notations. So there exists k, capital K. Fine. Okay, so this last step is clear. Last sentence is clear, whatever I have written.
Yes, sir.
Fine. That means what is the situation? X1, X2, and here X suffix K, the particular, right? Suppose my K is 100, then 100 onward, right? This is 100 term. If my K was, for example, then 100 onward, all terms satisfy this, right? Now, note that if small k is, okay, note that what is the relation between, so if you have any difficulty you can ask me, because I am going very slowly, because this thing is not, might be confusing. So note that what is the relation between nk and k? What is the relation between nk and k?
nk is greater than k.
Nk is greater equal k, because nk is a position in original sequence and k is a position in subsequence, right? And therefore the position on in original sequence is higher, because if you delete some terms, the terms get shifted to left side, so position reduces, right? Therefore if k is greater equal this particular k is greater equal particular k, this k which we found, right? Then what can you say about nk? Nk is greater equal k, nk is greater equal k, and k is greater equal k. Then what is the distance between x and k and x?
It would be
What?
less than epsilon because
Ha,
n is greater than k.
ha. So it is because what our first, let us call it as first expression. What first expression says? Ki if your n is greater equal k, the corresponding term minus x distance is less than epsilon. That means if your suffix is greater equal k, the corresponding term minus x, the distance of that term from x is less than epsilon. So what is suffix here? What is suffix here? Suffix here is, right? Suffix here is nk, and nk is definitely greater than or equal to k, right? Is it clear? And therefore the corresponding term, right? Corresponding term, its distance from x, is it less than epsilon? Can I say this?
Yes, sir.
Yeah.
Right. Thus, what we got here, xn k minus x is less than epsilon for all k greater equal this particular k which we found for xn. Right? Hence, given any epsilon, there exists k such that we can produce k xn k minus x is less than epsilon for all k greater equal k. Right? Therefore, what is limit as k tends to infinity? Xn k is x. So, therefore, subsequence xn k converges to x. Now we just select arbitrary. We select arbitrary subsequence. So this is true for every subsequence since we select an arbitrary subsequence of xn, we conclude that every subsequence of xn converges to right. Every subsequence of xn converges to x. So the proof is clear. Therefore, if sequence is convergent and it converges to x, you choose any subsequence that converges. Now, what is the importance of this theorem? What is contrapositive to this? What is a contrapositive statement to this? If limit xn is x, this is our theorem, and xnk is a subsequence of xn, then what we have proved? Limit of xnk is x. This is what we proved. Am I right?
So
Yes, sir.
Now, can you tell me this? Uh, that is, if limit of xn is x, then every subsequence xnk of xn converges to x. Right. This is what we proved. Now tell me the contrapositive statement. If then, right? So P implies Q.
If any subsequence of xn is divergent, then xn is divergent.
Yes, that is correct. So let me make it more precise. So suppose P is a statement xn converges to right, and Q is a statement xnk xnk is a subsequence xnk is a subsequence of xn, and R is a statement the limit of xnk is same number x, which is limit of xn. Then what previous theorem says? P and Q. P and Q means what? Xn converges to x, and xn is a subsequence of xn. Xnk is a subsequence of xn. What is the conclusion? What does this imply?
R.
R.
R, that means xnk converges to x. Logically, this is our statement. and therefore what is a contrapositive to this?
Negation of R implies negation of P and Q.
If so, there are many ways to say the contrapositive. What is this? We'll see different versions. If x and k is a subsequence of xn such that limit of x and k is not x, then certainly what you can say that then limit n tends to infinity, then either there are two possibilities. What are two possibilities? Limit of x and k is not x, then certainly limit of xn is not x, or limit of xn does not exist. There are two possibilities. If there is a subsequence which do not converge to x, either limit is not x or xn does not converge. This is one way. What is another way? If there is a subsequence x and k of xn such that limit of x and k does not exist. That means subsequence itself is divergent. Then what you can say? Then definitely limit of xn does not exist. Am I right? Why this is true? Because if limit of xn were exist, then by theorem every subsequence must converge. Correct? If limit of xn exists, every subsequence converge. But if there is a subsequence which do not converge, that means limit of xn does not exist. Am I right?
Yes, sir.
Now what is another version? Okay, again recall the theorem, statement of theorem. What statement of theorem says ki if xn converges to x, then every subsequence, either you take xnk or xnr, whatever, you take sequence with even suffixes and odd suffixes, every time the subsequence converges to the same number. Right? What is a contrapositive? Another version of this contrapositive. Do you understand? What is another version? If there exist two subsequences xnk and xnr of xn such that limit k tends to infinity xnk is not limit r tends to infinity xnr, then what is the conclusion?
Xn is divergent.
Xn is definitely divergent. Right? Because if xn were convergent, then these two subsequences would have converged to the same number. But that is not the true case, because we are assuming that these two subsequences converging to different numbers, and therefore original sequence cannot converge. If at all converge, then these two subsequences must have same limit. That is not true, right? So logically you should think about it. Whatever we have written, how logically it is equivalent to the theorem. Okay, read again. What is my first statement? Statement of theorem. If xn converges to x, choose any subsequence converges to x. It is equivalent to saying that if xn k is a subsequence of xn such that the subsequence do not converge to x, then xn cannot converge, or it cannot it converge but cannot converge to the number x. Or if there is a subsequence which is divergent, then original sequence must diverge. Or if there are two subsequences, they are convergent but they converge to different numbers, then original sequence is divergent. Is it clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now look at the example. Xn is equal to minus 1 raised to n. And now we have already proved that this sequence is divergent. But using this subsequence criteria, our question is Xn convergent? This is our question. Okay. Now, can I produce two subsequences which converge to the different numbers?
Yes, sir.
Right?
Yes.
So what is Xnk? X2k. And what are the terms? Right? And therefore, what is Xnk in this case? All one constant sequence, right? So, and xnk is a subsequence of original sequence. Is it true?
Yes.
And what is limit as k tends to infinity? Xnk is 1
One.
and xnk is a subsequence of xn and it converges to 1. On the other hand, let nr is equal to 2r minus 1. Then look at xnr, x2r minus 1. What is it? Minus 1 raised to 2r minus 1. And what are the numbers? Minus 1, because odd powers. Therefore, what is limit as r tends to infinity? X nr, right? Each term of subsequence is minus 1, right? We are just extracting the odd suffixes. In previous case, we extracted only even suffixes, right? So what is limit? Minus 1. Therefore, xnr is a subsequence of xn, and what is limit as r tends to infinity xnr is minus 1. What is the conclusion? Therefore, xnk and xnr are two subsequences of xn, but limit of xnk is not same as limit of xnr. Am I right?
Yes, sir.
Yes, sir.
And what is the conclusion of it? Because of previous theorem,
Xn is divergent.
xn does not exist. Limit of xn does not exist. That means xn is certainly divergent. Xn is certainly divergent sequence. Right. So therefore, you have to just pick up two subsequences which gives different limits. That is helpful. And so this criteria is useful if sequences are divergent. If sequence is convergent, then this criteria is not helpful because you choose any subsequence converge to same number. If you check this for 5, 10, 100 subsequences, will it be sufficient?
No.
Right. So if xn is convergent, then and you try for 2, 3, 4, right? You take one subsequence. If xn is convergent, every subsequence converge to the same number. Then if you check for 10 subsequences or 100 subsequences, every time limit is same, but that is not sufficient to say that the sequence is convergent because there are many subsequences which are yet to be checked, right? But if you identify at least two subsequences having different limits or one subsequence which is divergent, then we can immediately tell that The sequence is divergent. So then subsequences criteria is not useful. Is not not useful in the sense ki one taking 2, 3, 4 subsequences is not sufficient. So the subsequence criteria is useful when the sequence is divergent. Useful to prove that sequence is divergent. Right, that is the observation you can have. So these are logical things key what the statement says. Okay, let us look at another sequence. Xn is equal to sine of n pi by 2. Sine n pi by 2, is it convergent? Okay, let me write down few terms: x1, x2, x3, x4, x5. Right. What is x1?
1,
1.
1. What is x2?
0,
0. Sine 2 pi by 2. Right. Sine pi, which is 0. What is x3? Sine 3
-1.
minus 1. Right.
-1.
So what is x4?
0.
4 pi by 2. Sine 2 pi, which is 0. Now you can understand what is x5. X5 is 1, then 0, then -1, then 0, then 1, and so on. These are the terms. Now can you produce a subsequence which is divergent?
yes sir,
Right? Nk is 2k minus 1, and then what is xnk is x2k minus 1. It is sine of 2k minus 1 odd multiples of pi by 2. And what is sine odd multiple of pi by 2? Is minus 1 raised to k plus 1. Am I right? Minus 1 raised to k plus k. What is sine odd multiples of pi by 2? K or k plus 1? K plus 1, I think. Right. This is just by the from property of sine. Sine 2k minus 1 pi by 2. What is it? Minus 1 raised to k plus 1. Right. So what is x and k? Minus 1 raised to k plus 1. And is it convergent? Is it convergent?
no sir,
It is like minus 1 raised to n. Right. So x and k is divergent. And what we can conclude? Therefore, xn is divergent. Because we are able to produce a subsequence which itself is a divergent. This is one way. What is alternative way? Can you produce two subsequences? Both are convergent but not converging to the same limit?
Yes, sir.
Can, can you produce a two subsequences which converges to the same different limits? One of them is I can look at nk is equal to 2k, even suffixes. Then what is xnk? X2k, and therefore sine of 2k pi by 2. And what is sine of 2k pi by 2? Sine of k pi. And what is sign of k pi? What is sign k pi? K is a natural number.
0.
Zero.
0.
Right. And therefore xn k is 0 for all k. What is the limit of xn k?
0.
0. Now produce another sequence nr whose limit is actually what? Whose limit is 1. So nr
nr is
is
equal to 4, 3.
nr is equal to, suppose I choose first and fifth, first, fifth, and so on.
So then 5 are no?
Yes, 4r plus something. What? How to get formula for nr?
Minus
I just
4,
minus
3.
Okay,
So we
4.
can take 5 are only.
No. It is not fifth. We want which terms converge to 1, which first, fifth, then
9th.
9.
9. So what is the formula? I want general formula.
4r minus
Okay, right. 4r minus 3.
3.
Right. And what is xnr now? Xnr x 4r minus 3. So sine of 4r minus 3 pi by 2. And you check that key every time it is 1 for all r. You check this. Therefore, what is limit as r tends to infinity, xnr is 1. So these two subsequences xnk and xnr convergent, but they do not converge to the same number. This is another way to say that sequence is divergent, but here actually we have produced a subsequence which is divergent, so that is sufficient, right? But why I am telling this, because there are different ways to prove that it is divergent. Okay, so you think about this. Xn is equal to cos of n pi. You think about this. Right. You also think about xn is equal to sine of n pi by 4. You also think about 1 minus minus 1 to n plus 1 by 2, 1 by n. You think about this. Fourth, you think about 1 plus minus 1 raised to n. Right. Yes. Okay, you think about these subsequences and check which are convergent, which are divergent using subsequence criteria. Correct? Yes, any doubt? Because we should stop here. Whatever we discussed today, everything is clear.